Hi everybody, welcome to Mr. Curl's classroom. Today we're going to take a deep dive into the quadratic formula, so let's get started. Okay, so right now we're looking at the standard form of any quadratic, which is a polynomial with a degree of 2. And the standard form is ax squared plus bx plus c is equal to y. However, when we're referring to the quadratic formula, we're talking about the roots of that quadratic, or in other words, graphically speaking, where does that parabola cross the x-axis? So we're not really interested in where it's equal to y, because that gives us the entire parabola, all of it. What we're really interested in is where it's equal to 0, or where y is equal to 0, or where it crosses the x-axis, which is called its roots. Now, you guys all know that we can apply the quadratic formula, which is x is equal to the opposite b plus or minus the square root of b squared minus 4ac all over 2a. So what I want to talk about during this lesson is are these pieces made up of? What do they actually mean? And also, how do we even get the quadratic formula? So how do we get the quadratic formula is actually a fairly straightforward process as long as you know how to complete the square. So if you want to solve any quadratic, you can really use two options. You can either use the quadratic formula or you can complete the square. But actually, completing the square is what gives you the quadratic formula. I'm going to go ahead and show you what I mean by that. If we wanted to derive the quadratic formula, we would start with ax squared plus bx plus c is equal to 0, and we would solve for x. That's what we're actually doing that's what the quadratic formula says when it says x is equal to all of this stuff in terms of a, b, and c. All right, so how would we go about doing that? Well, we're just going to go through the completing the square process. So it's going to be a little bit more difficult, and I'm going to run through this fairly quickly because you're not responsible for knowing it, but I just wanted to just show you what it looks like. So to complete the square, first I'm going to go ahead and make some room for that perfect square by removing the c, or that constant term, out of there. So I subtract c on the other from both sides. Then I'm going to go ahead and pull out the a from these two terms, and when I divide that out, I'm left with x squared, but I have to list this as b over a because I don't really know what these numbers are, but it's going to be b divided by a, so I have to leave it like that. Okay? Then I'm going to clean this up by dividing the a by both sides, so I have negative c over a on this side, and now I'm ready to go ahead and complete the square. So to complete the square, I'm going to go ahead and take half of b over a, which is b over a divided by 2, or b over 2a. And I'm going to square that. So b over 2a squared is b squared over 4a squared. So that's how much I'm actually adding to both sides, so I need to be sure that I do add it to both sides. Next, I'm going to go ahead and write or factor this, I should say, this perfect square trinomial. So this becomes x plus b over 2a, and let me remove myself here so you guys can see. And then on the right-hand side, I just went ahead and cleaned this up by adding these two fractions. Next step is going to be take the square root of both sides. Make sure you have a plus or minus on the right-hand side because I'm taking the square root of an x squared on the left-hand side. And when I do that, the x plus b over 2a pops out. And on the right-hand side, I'm left with plus or minus. Well, this numerator, I can't really do anything with the square root of b squared minus 4ac, so we just leave it. It can't be simplified. But the square root of 4a squared can be simplified. That is a perfect square, and the square root of 4a squared is just 2a. And now the last step here is to subtract this term over. So I'm going to go ahead and put it in front. So x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And notice that these have 2a in common as a denominator, so I can go ahead and combine the numerator terms, getting x is equal to our quadratic formula. There you go. A little bit tricky, but really wasn't too bad to complete the square. All right, so that's where it comes from. You're starting with standard form, and then you're going to use completing the square in order to derive your quadratic formula. Okay, so let's go ahead and talk about what this means graphically now, as far as what each piece of this means, so we can kind of like dispel some of the mystery behind it. All right, hopefully, by the way, just showing the derivation got rid of a little bit of that mystery, okay? But either way, let's go ahead and I just want to remind you, if I have a plus b over c, then I can rewrite that as a over c plus b over c, okay? And that's what we're going to do with the quadratic formula. I have this thing on the left plus or minus this thing on the right all over 2a, so I'm going to apply the 2a to both sides of those. Oops. Brought up the wrong thing. Still bringing up the wrong thing. There we go. All right, so anyways, so this is exactly the same as the quadratic formula, except I'm splitting these two terms out, those two numerator terms, so they both get that 2a. So what I really want to talk about is what each of these mean. All right, so let's talk about the first one. X is equal to negative b over 2a, because then I'm adding or subtracting something to that. So let's talk about the left-hand side. So the left-hand side is really the axis of symmetry, or the middle of this parabola. And actually, if you didn't know the quadratic formula, you probably had been taught by your teachers that you can find that middle by just taking negative b divided by 2a. Well, where does that come from? Well, it comes from the quadratic formula. Negative b over 2a gives you that axis of symmetry, or that middle line right there. And more importantly, when we're talking about the roots, we're talking about the points along the x-axis. That is the exact middle between the two roots, which means that this is a really important number as well. What is this number? Well, it tells us how far the roots are to the right and to the left of that middle. Plus a certain amount, and minus that certain amount is how much we deviate from the middle to get those roots. Now, this has important implications, because this negative b over 2a is something pretty simple. But over here on the right, how much we go to the right and left, this is much more difficult because we have this square root. And specifically, I want to talk about the square root, because the issue is, if I had like the square root of 2, for example, if all of this b squared minus 4ac, which we call the discriminant under here, if it was just like the square root of 4, for example, this would evaluate to a whole number. So yes, it's fine. We can move to the right by 2 and to the left by 2, and that's totally fine, very easy. Or if it's any other positive number, it's really not that difficult for us to move along the x-axis, even if it ended up being like the square root of 5, for example. Well, the square root of 5 is some kind of decimal, right? And we can definitely move to the right and the left by some kind of decimal. The issue is that once this evaluates to a negative number underneath the square root, because we know that the square root of a negative number gives you an imaginary number. And so how do you go the length of an imaginary number along a real number line, the x-axis? Well, the answer is you can't, right? You can't. So if the discriminant under here, which we'll talk about in 1 second, b squared minus 4ac, if it's negative, then that means that this doesn't cross the x-axis, which we'll see in a second. Okay, so let's go ahead and talk about the discriminant. So as I said, the discriminant we're really interested in because it really kind of tells us what kind of solutions we have. And again, the discriminant, it does not include the square root. It's just b squared minus 4ac, and we investigate that for the different cases. And there are only a few different cases that are possible. First, like I said, it could be negative, and actually that's the easiest case. If you were to classify it when the discriminant is negative, then you would just say that it has imaginary roots, meaning it does not cross the x-axis. So it would look something like this, right? Where you can have the axis of symmetry, you can figure that out, but you will not be able to move to the right and left by real numbers. It's only imaginary numbers, which takes us up and off of the x-axis, okay? Could be up there, could be down here, but either way, it does not cross the x-axis. So if the discriminant is negative, we know we have two imaginary roots. Now, if it's positive, there are actually 3 different cases. The easiest being if it's 0. So if I end up with the square root of 0 under here, then this whole thing is just going to cancel out, which means I don't have plus or minus anything, right? It's just one solution, whatever negative b over 2a is, that's just a number, okay? So what does that mean? Well, graphically, let's talk about classifying first. So classifying, that means I have a real rational equal roots. So whenever I have a quadratic, I'm expecting two roots, okay? But what this is saying, if the discriminant is 0, that means I'm only going to get one root, but it counts for two. So maybe it's like right here. That means the parabola comes down and just touches the x-axis and goes up. Or maybe it starts down here, comes up and just touches it and goes back down. But either way, if it's 0, I'm not adding or subtracting anything, right? I am just staying right where I'm at, and that counts for two roots, and we call that a double root. Sometimes you might see double root. Other times you might see that is a root with a multiplicity of 2. Sometimes you'll see that as well. Okay? All right, so what if it's the discriminant is a perfect square? Well, if it's a perfect square, then we're going to end up with real, rational, unequal roots. So what is that going to look like? Well, let's just imagine I have something like this. Like maybe x is equal to 1 plus or minus. Well, if it's a perfect square, then maybe like square root of 4. Excuse me. So what does that mean? Well, this is actually 1 plus or minus 2, which I can evaluate to two real numbers here, right? So that is 1 minus 2, which is negative 1, and 1 plus 2, which is positive 1. So like maybe something like this, where it crosses at negative 1 and positive 1, or it could look like this, whatever. Don't really know what the parabola looks like, but I do know where it crosses, okay? But either way, you end up with two roots, and we know that they are real numbers and they are rational. What does it mean to be rational, by the way? A rational number is a number that can be expressed as a whole number over another whole number. So for example, if I said is 1 over 3 rational? Yes, that's a whole number over another whole number. If I said is 3 rational? Well, yeah, I could express that as 3 over 1, a whole number over another whole number. So those are what rational numbers are. All right. So if it's 0, we end up with a real, rational, but equal roots. If it's a perfect square, we end up with real, rational, but unequal roots. Okay? Now, if it's not a perfect square, so say for example I ended up with like x is equal to 1 plus or minus the square root of 2. Well, there's no way for me to simplify this square root of 2 anymore, so we call that an irrational number. Square root of 2 cannot be written as a whole number over another whole number, but it's still a real number. It still does exist. So we call that a real, or we classify it as a real irrational unequal roots. Okay? So again, if it was like plus or minus square root of 2, yeah, I can definitely go over to the right square root of 2 and to the left negative square root of 2, and I can cross those. Those are definitely real numbers. Okay? They just don't happen to be rational numbers. All right, let's continue. Now, with our knowledge, we're going to do a couple of practice problems. All right, so here we are with our first quadratic, and we have 4v squared plus 4v is equal to 3. Let's go ahead and see if we can solve this by applying the quadratic formula, and let's also refer to our classifications while we're doing it. Now, number one, this is not in standard form, so we do have to put it in standard form, so let's go ahead and do that. So I have 4v squared plus 4v minus 3 is equal to 0. And I usually put a nice underline under here once this thing is in standard form. So let's go ahead and apply the quadratic formula. So I have, oh, and you know what? For this first one, let's go ahead and label. This is A, positive 4 is A. This is B, positive 4, and C is negative 3. Excuse me. All right, so let's go ahead and apply the quadratic. So here we go. So I have x is equal to the opposite of b, so negative 4 plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is 4, times c, which is negative 3, all over 2 times a, which is 4. Let's go ahead and simplify. There are a lot of steps with using the quadratic formula. It's usually not hard to plug in, but there are a lot of steps, so make sure that you are meticulous as you're solving here, because there are a lot of opportunities to make mistakes. So anyways, so I have negative 4 plus or minus, and let's go ahead and evaluate the discriminant. So this is going to be 4 squared, which is 16, minus, well, it's actually negative 4 times positive 4, which is negative 16, times negative 3, which is positive 48. So we have 16 plus 48, which is equal to 64 underneath there. So we have the square root of 64 all over 8. Now, I'm going to go ahead and take a look at this discriminant right now. So it is a perfect square, and it's positive. So first of all, it is positive, so I know I'm going to get real solutions. It's a perfect square, so I'm going to get rational solutions. Nice whole numbers, or at least fractions of whole numbers. And they're going to be unequal because it's not 0 in this case. Okay, so let's go ahead and we are going to evaluate that. So I'm going to draw an arrow up here so I have more room. So I have x is equal to negative 4 plus or minus square root of 64 is 8 all over 8. Now all of these are divisible by 4, so we will divide everything by 4. So negative 1 plus or minus 2 divided by 2. And now you would not leave this as your final answer. You would evaluate both cases, the plus case and the minus case. Okay, so I'm going to say x is equal to the set of two different numbers. I'm going to get two solutions. So I'm going to do the minus case first. So negative 1 minus 2 is negative 3 divided by 2 is negative 3 halves, or negative 1.5. Now let's do the positive case. Negative 1 plus 2 is positive 1 divided by 2 is positive 1/2. So there we go. We have our roots at negative 3 over 2 and negative 1/2. So by the way, what does this mean? If I graph this, this is 1 and 2 and this is 1. That means at negative 1.5 and negative 1/2, we have our roots. So I don't really know what the parabola looks like, but I know it definitely crosses at those two points. Okay? Okay, let's do another one. Okay, so here's our next problem, and we are going to take 3x squared plus x plus 1 is equal to negative 5x, and I don't like that this is not in standard form, so let's go ahead and, whoops, I don't want to do that. I want to go ahead and do some algebra to put it in standard form. So I have 3x squared. I'm going to add 5x over, so plus 6x plus 1 is equal to 0. I'm going to underline that one because it's in nice standard form. And we'll go ahead and apply our quadratic formula. So I have x is equal to the opposite of b, so negative 6, plus or minus the square root of b squared, which is 36. 6 squared is 36, minus 4 times a times c. Notice I try not to do too many steps at once in my head, otherwise you'll be prone to make mistakes. Anyway, all over 2a, or 2 times 3, which is 6. All right, let's go ahead and simplify this, especially the discriminant, and talk about what types of solutions we're going to have. So, whoops, I have 36 minus, let's see here, 4 times 3 is 12, so 36 minus 12 is 24, all over 6. And so right away, I know that 24 is not a perfect square, right? But it is a positive number. So I know I'm going to have real solutions, two real solutions, but they're going to be irrational. Whoops, irrational. How do I know they're going to be irrational? Because I'm not going to be able to get rid of this square root completely. I will simplify it, but I won't be able to get rid of it completely. So they will be irrational. And they will be unequal. Yeah, even though it is irrational, I am still going to be able to add and subtract those from each other. So anyways, so let's go ahead and we will do that up here. So x is equal to negative 6 plus or minus. All right, so the square root of 24 is the same thing as the square root of 4 times 6. And if I separated those out, I could take the square root of 4 and pull that out as 2 root 6. All right, so this is plus or minus negative 6 plus or minus 2 root 6 all over 6. And now I can simplify this because all three of these are divisible by 2. So we will divide everything by 2. X is equal to negative 3 plus or minus the square root of 6 all over 3. And there we go. This is actually the most simplified version, so I'm going to leave it like this. Now you could actually split the 3 up between the first and the second term in the numerator. That is totally valid if you wanted to, but I'm going to go ahead and just leave it like this. All right, and make sure you remember the classification, because this does match up with what we said. Two real, irrational, unequal roots. All right, let's do another one. Okay, so in this problem, we have x squared plus x plus 1 is equal to 0. It's already in standard form, so let's go ahead and apply the quadratic. So I'm going to say x is equal to the opposite of b, so negative 1, plus or minus the square root of b squared, well, that's just 1 squared, minus, I guess I'll put a squared here, minus 4 times a, which is 1, times c, which is also 1. A lot of 1s here. All over 2 times a, which a is 1. All right, let's go ahead and simplify all of this. So x is equal to negative 1 plus or minus the square root. Let's see here. I have 1 minus 4, so negative 3, all over 2. All right, now let's go ahead and classify this. So this discriminant is a negative number, so I know that this is going to be two imaginary roots. Now you might be asking yourself, like, why don't we have rational and irrational imaginary roots? Yeah, we just don't have those. I don't really have a good answer for that. We just do not classify imaginary numbers as rational or irrational. They're just imaginary. That's it. Okay? But either way, this is actually, there is one thing I can do here. I can say the negative root 3 is equal to I times the root 3. Remember, we always pull that negative out as an I out front. So let's go ahead and write our solution. Excuse me, the solution's down here. Sorry, I had a little hiccup. X is equal to negative 1 plus or minus I root 3 all over 2. And there you go. Those are your two solutions. And what does this tell us? Well, it does tell us that this does not cross the x-axis. But actually, I also do know the line of symmetry. It is the line of symmetry is at negative 1/2. So if this was like 1, then the axis of symmetry would be here. But do I know where it's at? No, I really don't. I mean, it could be anywhere as long as it does not touch that x-axis. Okay. All right, anyways, let's continue on. Last problem here. Okay, so this one is definitely not in standard form, so let's go ahead and put it in standard form. And I do not like this negative x squared, so I'm going to move everything over to the left-hand side. So I'm going to say x squared. I'm going to subtract that 2x over. It's still just plus 1. And now I have nothing on the right-hand side, so it's equal to 0. Let's go ahead and apply the quadratic formula. X is equal to negative, or the opposite of b, so it's negative negative 2, plus or minus the square root of b squared, or negative 2 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times a. All right, so let's go ahead and simplify this. X is equal to negative negative 2 is positive 2. Plus or minus the square root of, let's see, negative 2 squared is positive 4, and then minus 4 times 1 times 1 is just 4, so that's actually 0, all over 2. So what is the square root of 0? Well, the square root of 0 is just a 0. So we're going to add or subtract nothing onto this, which means the add or subtract is gone. It's gone. So all we're left with is the 2 over 2. So let's go ahead and write that out. So I have x is equal to 2 divided by 2, which means that x is equal to 1. All right, so, and by the way, if we looked at this, remember, if we have a discriminant of 0, then that means we have real solutions, however, and real rational solutions. However, we just have one solution, or equal solutions, I should say, meaning it does count for 2 solutions, but it is a double root. Okay, so what does that look like graphically speaking? Well, in this case, if I had 1 over here, that means this parabola is going to come up and just touch 1 either that way or this way. Touch 1 and then go back up. Okay, not really sure of the overall shape of that, but at least we have some pieces of the puzzle. Okay, all right, guys. So that takes care of our lesson on the quadratic formula, and especially with a pretty heavy deep dive into how it's derived, what do all the pieces mean, and then also, of course, how to apply it, and really specifically looking at that discriminant, b squared minus 4ac, because it can tell us exactly the type of solutions that we're going to get, so that way we can validate the solutions that we do end up with. So, okay guys, hopefully this was helpful to you, and yeah, I'll see you in the next one. Have a good one.